Have you ever just stopped and wondered what is actually going on inside the mind of an AI like ChatGPT? I mean, you ask it to write an email or a poem or even a piece of code, and it just does it. But how? Well, today we're putting on our detective hats because we are going to try and crack one of the biggest mysteries in modern tech, the AI black box.
All right, here's our game plan. First, we'll get a handle on this whole black box mystery. Then we'll see how researchers are trying to crack the code. We'll even shine a spotlight on the real tools they're using, dig into the mysteries that still have everyone stumped, and finally, we'll talk about why this whole quest is so important for our future. So, let's start our investigation with the main problem, right? We've built these incredibly powerful AI minds, but we can't just pop the hood and see how they think.
Yeah, this is the big one, isn't it? When you type in a prompt, what is actually happening in there that lets a model spit out something so coherent and, a lot of the time, so creative? Okay, so at its core, a large language model, an LLM, is what we call a black box. And here's why. It's trained on this mind-boggling amount of text, basically a huge chunk of the internet, books, you name it. And from that, it learns all these patterns and connections in language so well that it can do this incredible range of things. But here's the catch. Its inner workings are super opaque. Figuring out its reasoning process is a massive challenge. So what makes these things so tricky to understand? Well, for one, we are talking about billions, sometimes hundreds of billions of parameters. You can think of these as tiny little internal dials the model tunes while it's learning. Then you've got emergent behaviors. These are abilities, like learning on the fly, that nobody explicitly programmed into them. They just appeared. And to top it off, knowledge isn't stored in one neat little folder. It's spread all over the network in these complex, nonlinear ways. You can't just point to one spot and say, aha, that's the part that knows about cats. It just doesn't work like that. But you know, a challenge this huge is going to attract some pretty smart detectives. So now we're diving into the world of AI interpretability, where researchers are coming up with some seriously clever ways to start cracking this code.
So these investigators are basically taking two main approaches. The first one is behavioral. Think of this like being an AI psychologist. You don't open up the brain, you just watch its behavior. You study what inputs lead to what outputs to figure out what it does. But the second approach, the mechanistic one, well, that's more like being an AI neuroscientist. You're actually going inside, looking at the circuits and the algorithms to understand how it really works.
And one of the key tools for that neuroscientist approach is something called probing. Imagine researchers want to find out if an LLM actually understands grammar. What they can do is freeze the main model and then attach a small, simple diagnostic tool, the probe, to its internal layers. Then they train just that little probe to see if it can spot grammatical things, like parts of speech, from the model's internal data. If that simple probe can do it, that's really strong evidence that the knowledge is baked right into the LLM itself. And this perfectly shows what they're finding out. Probing has revealed this really fascinating hierarchy inside the model. It seems like the model's lower layers, the ones closer to the input, they focus on the basics, the real nuts and bolts of grammar. But as that information moves up through the higher layers, the model starts to grasp more complex, sentence-level meaning and ideas. It's almost like it learns language in stages, from the ground up.
Now, going even deeper than probing, researchers are actually identifying circuits. So they'll start with a specific behavior, like the model's amazing ability to learn from examples you give it right in the prompt. Then, by painstakingly tracing the flow of information, they can actually isolate a small network of components, a circuit, that works together to create that behavior. And one of their first huge discoveries was the induction head, a specific type of circuit that seems to be a key reason in-context learning is even possible.
And this isn't just theoretical stuff, you know? There are real hands-on tools that researchers are building and sharing to make this whole investigation possible. So let's take a look at the detective's toolkit. Okay, first up, we've got LIT. That stands for the Language Interpretability Tool. It's an open-source platform that was built specifically to help researchers see and understand what these language models are doing. And this is where the investigation gets really hands-on. With a tool like LIT, you can feed it a model and some data and start asking really practical questions, like, where exactly does my model mess up? Why did it make this specific prediction? And this one's crucial. Is it consistent? Like, if I change a pronoun from he to she, does the model's entire logic or prediction change in an unfair way? LIT helps you uncover those hidden biases and behaviors.
All right, next up is a tool with a much more specialized job, BERTViz. This one is designed to help us actually see one of the most important parts of modern AI, the self-attention mechanism.
So, in a nutshell, BERTViz lets you see what the model is paying attention to in a sentence. See, when an LLM processes text, these things called attention heads are constantly making connections between words to build context. And with BERTViz, you can literally visualize those connections. You can see how the model links a pronoun back to the person it's talking about, or how it understands the relationship between a subject and a verb. It's like a window into how the model actually built meaning.
But even with all these incredible tools and techniques, let's be clear, this investigation is far from over. In fact, some of the biggest mysteries about these LLMs are still completely unsolved.
And maybe the most famous unsolved mystery of them all is this one: hallucination. I think we've all seen this. You ask a question and the LLM just confidently makes something up. A fake historical event, a scientific study that doesn't exist, a legal case that never happened. This habit of generating baseless information and presenting it as fact, that's what researchers call hallucination. And it is a massive barrier to trusting these systems.
So why does it happen? Well, there are a lot of suspects. Sometimes the model just doesn't have the really niche knowledge it needs. Other times, it's possible that repeated data in its training set actually made it dumber in some ways. But a key theory is that the model is just relying too much on memorizing patterns instead of actually reasoning things through. It learns a shortcut, like noticing that sentences with certain words often lead to a certain answer without ever truly understanding why. And this leads to this huge internal debate for the investigators themselves. When they find an explanation for why the model did something, how do they know it's the right one? This is the battle between faithfulness and plausibility. A plausible explanation is one that just makes sense to us humans. But a faithful explanation is one that reflects what the model is actually doing inside its own black box. And an explanation can sound perfectly plausible but be completely unfaithful, meaning we're just telling ourselves a nice story that isn't true.
So, we've looked at the mystery, we've seen the tools, and we've touched on the really tough challenges. But let's bring it all home. Why does this quest to crack open the black box really matter for all of us?
Well, the payoff is huge. Interpretability is how we debug these things and fix their flaws. It's how we audit them for harmful biases and stereotypes to make sure they're fair. And on a bigger scale, it's how we make sure these incredibly powerful systems are safe and aligned with our values. I mean, as we start using AI in really high-stakes fields, like medicine or finance, being able to trust their reasoning isn't just a nice-to-have, it's an absolute necessity.
Ultimately, this whole push for interpretability, it isn't just some academic exercise. As this quote makes really clear, it's an ethical responsibility. When you put technology this powerful out into the world, you have a duty to understand how it works and to make sure it works for everyone's benefit.
And that really leaves us with one final critical question. As these AI models get more and more woven into our lives, and as their abilities keep growing in ways we can't always predict, is taking the time to truly understand them just a choice we can make? Or is it an absolute necessity for building a future we can actually trust?